Welcome back, I'm that chemist, and today we have a story where kids have an acid fight. About the thermometer story. When I was 14, I had a friend in my class who discovered that you can eat glue sticks. Spoiler alert, I would not recommend that anybody eats glue sticks. Just because you can doesn't mean you should. Most brands didn't taste that great, but he seemed to really enjoy the yellow ones, named after a big nocturnal bird. I wonder which one that could be. He said they taste like vanilla. Nothing happened to him, but he had to hide his snacking habits from the teacher after she discovered his special liking for the yellow bird named glue sticks. This was in the early 2010s. Yeah, I always hear stories about kids eating glue, but I didn't personally know anybody who ate glue. If you are a glue eater, you can let us know down below. Another Bagley Hall incident. This occurred in the early 1970s. There was a mercury spill in one of the hallways on the third floor. The hazards people were summoned, and they showed up with a vacuum cleaner to suck up the mercury. Unfortunately, they were using the outflow hose. The usual suggestion to deal with a small mercury spill is to cover the area with powdered sulfur, wait a while, and then clean it up. Yeah, sucking up mercury with a vacuum sounds like a terrible idea because it'll atomize and go absolutely everywhere. When I was about 10 years old, my dad had a can of air duster computer cleaner. I played around with it and quickly figured out that you could take out the cryogenic liquid gas by turning the can upside down. I also decided that it would be a good idea to fill up my small bottle cap with the liquid gas and try to light it on fire in an enclosed garage. It turns out that burning air duster like this produces HF. If you're wondering why this is the case, it's because it often has a blowing agent similar to difluoroethane. There are other ones that are used, but difluoroethane is one example of one that when you burn it, it will produce HF. I got several breathfuls of HF while trying to evacuate the gas chamber that I had just created. I had severe irritation and couldn't stop coughing for 15 minutes straight and was severely nauseous for the rest of the day. Even months later, I would still break into coughing fits. So the takeaway here is to not burn random gases that are used as aerosols. Maybe only start fires with things you're supposed to start fires with. High school shop, not a lab. The teacher was melting down donated aluminum to make ingots for students to use in projects. Always know what materials you're working with. Some of the aluminum was not aluminum and was actually magnesium, and when he opened the furnace to retrieve a crucible of mostly molten aluminum, it exploded and splashed him with molten metal. Oh my gosh. Luckily, he had had glasses, goggles, a face shield, and a leather smock. So this is a case of a close call, and you can see why we always suggest to be safe on this channel. If you have any good molten metal stories, make sure you let me know down below, but I have one of my own. So when I was younger, I was obsessed with bismuth. Bismuth was the first thing that got me excited about chemistry, and so I had got some to melt. So I melted some bismuth crystals, and I decided I'd try and grow crystals on my own. And so I did this a bit, I played around with it, and I ended up getting crystals to grow, nowhere near as big as the crystal that I originally started with. But one time I decided to try what would happen if I just put the molten bismuth right into water. And so I did that, and I got sprayed in the face with molten bismuth, and I wasn't wearing goggles, but fortunately it was only a very small amount that I was testing, so I didn't get any scars or any permanent damage, but that scared me enough to always wear my lab goggles forever after that. I am a stickler for wearing lab goggles, and if anybody comes in the lab when I'm in there without goggles, it is the first thing I will say, and I don't care if they're my supervisor or not, they better be wearing goggles. I was a fairly young kid, maybe 7 or 8, when my interest in chemistry began. My mom bought me a red cabbage-based pH indicator kit to learn about pH scale and the pH of common household items. My mother made sure that I was always wearing protective goggles while I was doing my little experiments because she was very concerned about my safety. She made it clear that chemicals getting into my eye, even just household ones, could cause damage. One day I accidentally got a little bit of the red cabbage pH indicator into my eye through one of the vents in my goggles. I washed my eyes out for several minutes and started crying because I thought I had just permanently damaged my vision forever and that I would never be able to see again normally. This escalated until my mom had to come calm me down. Looking back, this incident probably is the source of all of my modern chemical-related anxiety. We've had stories on this channel that involved people permanently losing their vision from exposure to a chemical, so it's definitely not a crazy fear. We don't all know all of the hazards associated with every single chemical, and even if you put 100 of us in a room, we still might not know the specific hazards associated with this specific chemical. And that's why we always look into the hazards associated with said chemical before we work with it, because you don't know the risks of what you're working with, and as a big sack of chemicals, putting in random other chemicals often messes stuff up. I think a good first exercise in lab safety is to paint all hazardous surfaces with concentrated capsaicin extract and see who thinks they know better than the PPE procedures. Yeah, I think these types of demonstrations would really go a long way. Some people think that they're smart enough that they don't need to follow the rules, and this would be a quick way to figure out that they do. The story about the hydrazine made me cringe. Back in the early days, they used to mix hydrazine into nitromethane for top fuel drag cars. And since nitromethane contains its own oxygen, and hydrazine scavenges oxygen, It made the fuel extremely unstable, and after a while it would form crystals in the bowl of the carburetor, and if you accidentally bumped it with a spanner, the shock was enough to cause it to explode. They only mixed it to a ratio of 5% hydrazine and it still killed people. The worst part is the combustion gases from the exhaust was toxic enough to send the pit crew and several spectators to the hospital. I've heard stories where they took a Ford Flathead V8, which made around 90 horsepower on a good day, and on hydrazine nitro they would make close to 300 horsepower. Wow, that's crazy. Running hydrazine nitro is now banned/illegal pretty much everywhere. Yeah, I think it's probably good that we got rid of that, because that sounds extremely dangerous. If you've got any other car-related stories involving chemicals, I'd love to hear them. I had an excellent teacher for high school chemistry. He'd been an industrial chemist before becoming a teacher, so he had lots of good stories and took us on a field trip to the local cellulose acetate plant, which was quite an olfactory experience. Also, he had an excellent, tremendous beard. Depending on one's tastes, the worst dangers in class, or one of the best, was that he also played in a bluegrass band, so he occasionally brought in a guitar and serenaded us and the rest of the school with things like a love song between a chlorine atom and a sodium atom, featuring a chorus about "I'll change your name from chlorine to chloride. I'll change your name from chlorine to chloride." Apparently someone else's rendition of that one is now on YouTube, titled Sodium Chloride, a love song of science, for the rest of you. I will put a link to that here in case you'd like to check it out. Microbiologist here, did my PhD in a Clostridium perfringens lab, causes a lot of bad things from mild food poisoning to fatal if untreated gas gangrene. We collected our biohazard waste from doing spectrophotometer readings into a glass Erlenmeyer vacuum flask. I was changing out the flask, not wearing safety glasses or a lab coat, and when I pulled the rubber vac hose off, the flask wound up smacking the bench and shattering. Yeah, that has definitely happened to almost anybody who's done practical lab work. The contents of the flask, perfringens, culture, lab strain E. coli, various protein measuring reagents, etc., go everywhere, including all over me. Oh no, that's terrible. Thankfully, I didn't get cut by the glass, but my clothes were soaked. Stripped down to my underwear, which was dry, thank God, I threw my clothes into a pile and poured bleach all over it. Grabbed a lab coat to cover up, cleaned up the rest of the mess, and had my wife bring me a new change of clothes. Honestly, I think even the crappy absorbent style of coat that we had would have let the culture through, but I still should have been wearing it. Thankfully, nothing got on my face, but I definitely should have been wearing glasses. Yes, this is a perfect example of why we wear PPE, but biologists have stuff that can get in your eye and give you an infection, so biologists should definitely be wearing lab glasses. Back in my high school days, we did some basic stuff to learn the ropes, and being in high school, kids will, at times, be kids, especially if you give them toys. One of the things that we used then were plastic eyedroppers, and sometimes during a lab activity, a couple of the students got it into their head that it would be fun to use them as water guns and spray each other with them. Oh no. It didn't take long for one of them, with an empty eyedropper, to reach for one of the filled ones, not with water, but with HCl for the lab, and spray it at their target, who dodged. Who didn't dodge? The guy at the next table actually doing lab work, and he got acid sprayed down the back of his shirt. The students involved in the acid fight incident were suspended. The unwitting victim was treated and back in class the next day. Being in the next classroom over, I only ever caught one glimpse at his back, after it had been treated. The lessons you can draw from this? Oh, so many. Yeah, maybe don't have acid fights. Maybe stay away from the stupid people who do stupid stuff. There's an expression called hanging out with all the wrong people, and I think this guy was definitely hanging around all the wrong people. I don't remember many details of this, but one time in high school, our aging, grumpy, and sometimes rude chemistry teacher took us to the school lab to show us a setup for generating hydrogen sulfide gas. This is already terrifying. I don't remember the reaction. It was something involving iron, I think. And so we stood there as we started to smell that oh-so-familiar odor. We were told that while yes, it is toxic, the concentration isn't high enough to hurt us. I would severely doubt that, as someone who's made hydrogen sulfide from something containing iron. After a while, we went back to the classroom, the smell still lingering in our nostrils. The next day, we learned that the whole school could smell it too. Too long didn't read, our chemistry teacher released a bunch of hydrogen sulfide all over school as part of a demonstration. Yikes, if you ask me. Yeah, that is super duper yikes. Hydrogen sulfide can be so toxic that you stop smelling it and it will just end you. Hydrogen sulfide is like a reagent for apoptosis, but for your whole body. That was a really stupid joke. Not a super crazy story, but when I was in high school, I used to work at a swimming pool store that sold, among other aquatic-related items, the chemicals that you use to tend to the pool water. I'm almost finished with grad school at the moment, in the process of writing my dissertation, but this was my first real experience being around bulk chemicals. One of the things used to lower the pH of the pool water is, unsurprisingly, hydrochloric acid, also known as muriatic acid. At the time, I didn't know exactly what that was, so I asked my boss, who told me it was dilute hydrochloric acid. Oh cool, that's not too bad, I thought. The bottle had showed the concentration of hydrochloric acid in weight per weight percent, And having recently learned those conversions in chem class, I did the math and looked up how concentrated it was. Turns out it's not diluted at all, and it's full on 35%, nearly max concentration. Worse than learning this was remembering stories from some of the customers about completely unhinged usage. I remember distinctly this one guy telling me about how great this acid stuff was, and that he would pour it out on his driveway and on his lawn to kill weeds. Yikes. We sold a gallon for like $5 too. Nothing dangerous explicitly happened that I know of, but I shudder at how many completely untrained people are handling concentrated hydrochloric acid and pouring it onto whatever they want, probably with no gloves or safety glasses, just willy-nilly. So yeah, I think everybody needs to understand chemistry because this kind of thing happens, and you could just go to Walmart and get chemicals, okay? Like, if you're allowed to just buy chemicals, we need to make sure that people are properly educated about how to safely utilize chemicals in the intended manner for their use. Fun fact about the superbug colonized soap. We were told at medical hygiene class that bacteria, when exposed to the same antibacterial compounds over a lot of generations, start to develop resistances the same way that they become antibiotic resistant. I'm not sure if it's the same way, but it's the same idea. So the janitor skimps out on the disinfecting solution and makes it more dilute. A good recipe for a hospital outbreak. The hospital uses the same solution for more than a year. Same here. Yeah, that's pretty scary. So the issue here is that some of the bacteria will be sensitive to the less concentrated solution, and they will still die. However, the stuff that doesn't die just survives, and then you have those resistance genes passed on. And so you need a sufficiently concentrated solution to wipe absolutely everything out so that none of those genes can get passed on. Yikes. This is a further example of why I believe chemical education is a necessity for everyone at this point. To any inexperienced chemists out there, never add water to concentrated acid. The phrase to remember is, add water to acid, you'll get blasted. If you're needing to dilute an acid, measure out the water and add the acid you'll need, and add the acid to the water. And if you ever need to prepare a standard solution, a clever trick that you can do is add the majority of the water, let's say 70 or 80%, dissolve all of the acid or base, and then top up to the correct volume. This is how you can prepare solutions for a volumetric flask. Now, the important thing is not to do this mixing in the volumetric flask, as that can negatively impact the health of the flask. So it's necessary to prepare the solution first and then do quantitative transfer by rinsing the beaker that you did this in with deionized water. The HCl incident reminds me of a story my dad told me about how he filled up his parents' basement with chlorine when he was a teenager, after my grandfather bought him a box of surplus reagents and glassware from some chemical plant site that he went to. Needless to say, my grandpa was not happy. I mean, when life gives you lemons, you make lemonade. And if you give someone the reagents to make chlorine and you don't supervise them, maybe they're going to make chlorine. You never know. I don't work in science, but if someone tells me not to use a safety shower, they're going to get a safety fist. This is probably my favorite comment on the channel so far. Today's Yikes awardee is E.R. Price. When I was in my first year of my undergrad degree, we had a practical chem exam. We would go into the lab and repeat the experiment we had done previously, but with no help, and we couldn't have a procedure in front of us. The experiment that I had to do is a simple acid-base titration using hydrochloric acid and sodium hydroxide. However, we were short on time, and I had forgotten to label which beaker had the acid and which one had the base. I didn't have time to go get more, and since we didn't have any pH or litmus paper, I decided to taste the solutions while nobody was watching. I remembered that we had been taught that acids tasted sour and bases tasted bitter, and that's the story of how I tasted hydrochloric acid. It worked, as I got full marks, but it's probably not something I'd try again. You should definitely not be tasting anything that you're doing in the lab. That is a recipe for disaster. There are plenty of stories where people tasted stuff in a lab and it went wrong. This is not one of those cases, but that doesn't mean that you should taste stuff. Safety first. My dad contracted chronic lymphocytic leukemia later in life. He worked on cars as a hobby and routinely washed grease off of parts and his hands with gasoline, which is full of benzene and other compounds that are terrible. I've always blamed his cancer on all of that exposure. However, there's another hobbyist exposure that I've noticed, brake cleaner. Brake cleaner is a popular cleaner. Some brands contain hexane, while other brands contain carbon tetrachloride. I have used both. My safety protocol for the carbon tetrachloride is much more stringent. Honestly though, I'm not sure that there's a difference in performance. I should probably stick to the hexanes. Oh, and always double glove if you care about exposure. I honestly don't know why we're still selling carbon tetrachloride to people as brake cleaner. It's hard to even get it as a chemist, so I don't know why normal people should be allowed to work with it if it's hard to get in a chemistry lab. If there are still products on the market containing carbon tetrachloride, comment about them down below. I'd be interested to know. Maybe we can make an episode about chemicals in consumer products that should be removed, and maybe we can get some attention to those problems. I would definitely be interested in making videos on that topic. If anyone could discover or invent cyclomethane, it would be Figueroa. Oh yes, maybe cyclomethane can be made after all. Just using acetonitrile, copper, hexane, methanol, and agua. Have a great day.